Let's talk about graphing inequalities in two variables and take a look at this example. If we want to graph the inequality x plus 2y is greater than 6. The first thing that we're going to do is we're going to graph the corresponding line where we actually think of, rather than an inequality right here, we think of what would this look like if this was an actual equation, like x plus 2y equals 6. And so we actually have two ways to do that. We can put it into slope-intercept form, y equals mx plus b, or we could use the intercepts to graph. So let's go through and actually do both of those just for some practice. And so the first way, if I wanted to use, I got to zoom in a little so I have some space here. If I wanted to use slope-intercept form, so slope-intercept form y equals mx plus b. If I want to use that form, I have to solve this equation for y. So I'm going to come in here and I'm going to say, okay, so let's take our x plus 2y equals 6. Let's subtract x, solve it for y, so we have it in the correct form. So 2y equals negative x plus 6. Divide by 2 on both sides, so that y is actually negative 1/2 x plus 3. So what that means is that my y-intercept, which is the b value, my y-intercept is at 0, 3, and my slope is negative 1/2. Now I push the negative into the numerator because I'm going to use that slope as my rise over run. And so the negative 1 will tell me to actually go down 1 unit and over 2 units. So if I wanted to use slope-intercept form to graph, then I can come over to the graph and I can plot that point 0, 3. So on my graph here is 0, 3, and there appears to be a graph up at 6, but let's not worry about that. Somehow I had an extra dot there. So we're at 0, 3, and then we're going to go down 1 unit and over 2. So using the slope, we go down 1 and over 2 units to get to a new point. So down 1 over 2, using that rise over the run, we plot our second point right here, and then we have a line. Now, before I actually graph the line, what I want to do is I want to just show, well, let's do the line. I'm going to do it in a gray, just because I would like to get a line on there. So let's scooch this ruler in here, and let's do it in pencil. Get a little line in here in pencil for now. Okay. All right. So let's talk about the other way to graph. The other way to graph is to use the intercepts. So you could also use intercepts to graph. And then we'll come back to the inequality part of this in just a second, but let's use intercepts to graph. So if we're going to use the intercepts to graph, I like to organize my intercept work just in a little table. I'm trying to find the x and the y intercepts. So the y-intercept is going to be when x is 0, and the x-intercept is when y is 0. And I just plug those into this equation. So where's my equation? Up there in red. So I've got x plus 2y equals 6. And if I plug in, and I'll show the work over here, if I plug in x equals 0, I would have 0 plus 2y equals 6, divide by 2, so that y would be 3. So that would be 3. And then if y were 0, so take my y equaling 0, and I would have x plus 2 times 0 equals 6. And that would give me x equals 6. So that would be the ordered pair 6, 0, and the ordered pair 0, 3. Now, we already have 0, 3 plotted up here on this graph. If I was using the intercepts, then I would be down, and I can see that my little line is actually, it's probably because I didn't do the greatest job with my ruler. It looks like I actually did 2 lines there. So we would be down here at this point here, which is at 6, 6, 0. So now let's bring in that ruler and connect all of those points. And obviously you only need one way. You only need to do this. You just need to graph that line. It doesn't matter if you graph it with a slope-intercept form or if you graph using the intercepts. You just got to get that line graphed. That's the first step. Okay, and I'm doing it in pencil on my screen, which is this gray line, because our next step, so our steps are to graph that corresponding line, right? So to get in there and graph that corresponding line. Now here is the next step. The next step, after we graph that line, we're going to think about what the inequality is. If it's a strict inequality or if it is a either or. So is it a strict inequality, meaning is it strictly less than or greater than, or can it also be equal? Can it be greater than or equal, or less than or equal? And so if we have use a solid line, if we can be equal, so use a solid line for less than or equal or greater than or equal inequalities. So when you're graphing that line, you will use a solid line if you have those inequalities. The other option, if it is a strict inequality, a strictly less than or strictly greater than, you are going to use a dashed line for what we call the strict inequalities, a less than or greater than inequality. So now we come back, and my steps have run a little bit into my example here. So let's separate them here. So now we come back and we look at our inequality. Now we come and we look at this piece right here. And notice here it says that this has to be x plus 2y has to be strict. It's a strict inequality. It has to be greater than 6. It cannot actually be equal to 6. So this is where we come in and say, oh, I actually have to have a dashed line here. So remember the pencil line I put in here? Now we're going to come in and say this should actually be a dashed line, not a solid line. And I know it's kind of hard to see. If I had a pencil, I would just be erasing in between. And so now I'm going to come in and use my eraser. Okay, so now the third step, and again, I have to kind of come over here. I'm going to bring my third step right here. My third step now is to decide which side of this line I should shade. So this line has cut the grid, the graph, in half. It has come across at a diagonal, and we have this portion above the line and this portion down here below the line. And I have to decide which of those two sides I want to shade, which side will contain all the points that will actually satisfy the inequality. So let me write the inequality up here again at the top of the screen. So it's x plus 2y is greater than 6, because it's off to the side now that we've moved over onto the graph. So our third step is to determine the correct shading. So determine which side to shade. So which side of the line, I guess, which side of line to shade for the solutions. So where do the solutions live? Are they above the line or below the line? And so the easiest way to do this, and the best way to do this, is to pick a test point. So pick a test point. I'll put that in parentheses. That's probably the best way to do it, is to just pick a test point. So for this particular one, you can pick a test point. It can be any point that is not on the line. So I find the easiest, so what we can't do is we can't pick the 2 points we use to plot, right? Those are not options for our test point, so I'm going to erase those. But we can pick any other point that's not on the line. So like 0, 0 would be a good test point. We could pick something over here like 5, 5 could also be used as a test point. Okay. Either of those 2 points would be good. In fact, there's an infinite number of points. I mean, you could pick this point down here and this point up here, as long as it's not on the line. So identify the point that you want to test, and then you're going to test it. And so when we test the point, and I'm going to write this over here. So when we test the point, identify, first of all, when you're writing out what your test point is, let's write what it is. I'm going to go with 0, 0, just because that seems like an easy one to plug in. And we're actually going to plug it into the inequality. So you determine which side to shade for the solutions. You do this by picking a test point and plugging it into the inequality. So I'm going to take that test point. I've got x plus 2y is greater than 6, and I'm going to plug in 0, 0. So 0 plus 2 times 0 greater than 6. And I find, obviously, that's 0. That's why 0, 0 is easy, because it clears out those terms. So 0 is greater than 6. Well, this is a false statement. So what that means is that 0, 0 is not a solution. So I want to make sure that my shading does not cover 0, 0. So if my shading cannot cover 0, 0, that means that my shading, remember there was only 2 options. So that means my shading must be on the opposite side of 0, 0. Okay, so it has to go, my shading cannot cover 0, 0. Now this little scribble that I just made means that everything above this line is included in the solutions. So that's how we do a test point. Now if 0, 0 had been a solution, then we would shade so that our shading covers 0, 0. So let's make one more little note down here. So pick a test point and shade the side of the line that contains the solutions. Okay? So if your test point, what that means is if your test point is a solution, then you shade over your test point. If it is not, you shade the opposite side. Okay? All right, so we have gotten to our answer, went through a couple little just things of review. You obviously don't have to go through both of these methods when you're doing your graphing of the line. Just get your line graphed, however you graph it. Use a solid line if the inequality includes an equal sign, but use a dashed line if it's a strict inequality, so if it's just strictly less than or greater than. Then pick a point that is not on the line, test it, and shade the side of the line that will contain the solutions. So if your test point does not work, like in our case, we shade the opposite side. Now, if 0, 0 had been a solution, if we'd gotten a true statement, then we would have shaded over 0, 0, the side of the line that contains 0, 0.